All right. So what is an arithmetic sequence? An arithmetic sequence is an ordered list of numbers in which the difference between each pair of consecutive terms or numbers in the list is the same, which is known as the common difference. So arithmetic is like linear. In a linear situation, you have a slope. In arithmetic situations, you have a common difference. The common difference is a constant addition or subtraction. It's always addition or subtraction. And it's of the same number, just like in a line. So make sure you're writing this stuff down. So common difference is a constant addition or subtraction. If you do not have a constant addition or subtraction, it is no longer arithmetic. All right? Just kind of like a constant rate of change with a line. If you don't have a constant rate of change with a line, it is not a line anymore. So what are some differences between linear versus arithmetic? Just so you guys know the difference here. Because they're very similar. On graphs, in a linear, you connect the points for linear problems. For arithmetic, you do not connect the points on a graph. For a linear, you always start at 0. For arithmetic, you always start when x equals 1. In this case, our x is an n. So I'm going to put So those are just some differences there before we get into notes. Notes aren't that long today. That's why I was able to get through other stuff.
Why is that n? Like, why did you put n?
N is its place in line. That's what they use for arithmetic sequences instead of x, like in slope intercept form. So it's like a place in line. So, and our place in line always starts at 1. Get that stuff written down. If you have rulers, hold them up in the air so I can grab them.
I just have 2.
When you're ready, also flip to the next page. I know some people are still copying stuff down. Very soft, or what did you say? Woolly? I feel like it kind of looks like a grandma sweater. I haven't decided if it does or not.
I mean, my grandma doesn't wear sweaters.
Same.
My grandma lives in Florida, so I wouldn't know.
Hopefully not wearing sweaters in Florida, right?
My grandma, she lives in Florida.
Thank you.
I'm so hungry.
She's a hip grandma. She also watches Real Housewives of Orange County.
Your grandma just gets better and better with every story.
I like orange
Did
stuff.
anybody get chased
I
by
like orange
Jason?
stuff. It's my favorite. I'm not sure you ever brought my dad.
Did you get chased by Jason on Halloween?
Does he have your cup, or is that actually
We
his?
make up Halloween by Rob Zombie. I'm not gonna say. I don't think.
No, I don't even have one. Oh my god. I forgot at home. I was going to bring it to say that too.
I didn't know if he stole it from you.
Brad, did you watch scary movies last night?
Ooh, maybe. Where's B Halls again? What is it off of?
Highway K, I think.
Nasty, Josh.
Does your brother still work there?
Yeah.
Do you work there?
Sometimes I'm starting.
Is your brother working tonight?
You're gonna fall over.
I don't think so. It's Wednesday. I think he is. Yeah.
All right, I think we are ready to move on.
Wait, did you watch any scary movies?
All right. No, I hate scary movies. Moving on. Hey, Mike, that means get back to your seat.
I was gonna say, if you were out on Halloween Adventure Farm, you would have been even more because Jason was running around with the chainsaw. So was Michael Myers.
I'm more of a scary game guy myself, because there's no limits on games. You get crucified. It's completely fine.
Yeah. That's what happens when you play Outlast 2 hours.
No, I only have
Hey, guys.
8 days on it.
On my chair, put it face
I
down.
only have like 8
Is your name on it?
76 hours on the first one. 8 days. What? Jana.
We have to use that.
All right. So using the figure, complete the table, plot the points, and describe the pattern of the y values. So, first of all, how many, so it's the number of sides on the star. So, how many sides are on this star?
1.
It's not 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Man, I love math.
What? Not times 2 necessarily. Be careful with that. Because it's not the previous times 2. So you have to think about that. How many sides are there when there's 2 stars?
20.
Okay, I'm going to call on people because this class can't not talk. So Tanari, how many when there's 3?
30.
Good. And Jayla, how about when there's 4? 40. And Brian, how about when there's 5? Okay. Notice, first of all, that we're starting when n equals 1, right? N means arithmetic, which means we do not connect the points on the graph. It is not a constant thing. You don't just have partial stars, do you? I mean, you can draw partial stars, but do we have partial stars?
No.
No, so it's not going to go, you're not going to be able to have a continuous line because it's not continuous. You need a star, then 2 stars. Does that make sense?
Oh, yeah.
It doesn't have like 11 sides, then 12 sides, then 13 sides. It's not continuous, so we do not connect. So it means arithmetic, do not connect. So plot your points, but do not connect them. That's why I took your rulers away from you. All right. Do you guys know what the pattern is? What is my common difference?
It goes up.
5.
5, 10.
So the common difference is 10. No. All right, so questions on that first one there. Okay, the next one is the number of circles. So RC, how many?
Forgive me.
He said master.
Master Variety.
Okay, so how many circles are there, RC? Thank you. Josh, how many are there when n is 2?
4.
No. Count them. How many circles are there?
3.
You're still...
Look at you.
Guys, whoever I call on is answering me, people.
I was just being
Connor, 3. How many is there? Justin Powers, when n is 4, how many is there?
5.
When n is 5, how many is there?
6.
Jordan? Okay. So we notice that there's an n here. It's arithmetic. We're not going to be drawing partial circles. Are we going to be drawing partial circles? No. You're going to go from 1 circle to 2 circles to 3 circles. It's not going to be continuous, right? So we don't connect the points. We just plot them. So at 1 there was 2, then 3, then 4, then 5, and then 6. We do not connect the points. Connor. What is my common difference?
Me?
Your name is Connor.
Oh. I'm the second one. 1.
So the common difference is 1. So questions so far?
No, not yet. This is a lot easier than.
Yeah, I like.
We're gonna write equations tomorrow. Don't worry.
I like counting the sides of shapes.
Yeah.
It's all going downward from.
It's the same thing as the rate of change. Yes. Guys, stop talking. I had a good question, and you guys won't stop talking. So let's ask how do you find the common difference? It's the same thing as finding the slope of a line, right? You see how much it goes up? So as this goes up by 1, this is going up by 10, so 10 over 1, 10 over 1. This is 1 over 1, so that's why it's 1. Does that make sense? It's the same thing as like finding slope. That's arithmetic and linear are very close. There's just like differences. Like arithmetic do not get connected. They're sequences, meaning they're at exact points. They're at exact numbers at 1, at 2, at 3, at 4. You can't connect it because they don't have those in-between numbers. Does that make sense?
Yeah.
All right. So decide whether the sequence is arithmetic or not, and if it is arithmetic, tell me the common difference. So Mike, is 5, 1, negative 3, negative 7 arithmetic? Okay, so we always start at 1. So this is when n is 1, it's 5. When n is 2, it's 1. When n is 3, it's negative 3. And when n is 4, it's negative 7. And you said it is arithmetic. What is the common difference? Mike, what is the common difference? What is it?
Negative 4.
What is it? You've said 2 numbers. Which one is it?
Negative 4.
Okay. So we always start when n equals 1, and this is your output. Please stop talking. Stop. So they give you the outputs originally. You just have to understand that that means when n is 1, 2, 3, and 4. So these are n's, and these are the outputs. Lexi, is this second one arithmetic?
No.
No, it is not constantly adding or subtracting. It's actually dividing. So not arithmetic.
Wait, it says decide whether the sequence is arithmetic.
I'm moving, jeez.
Okay, so you can write neither. Not arithmetic means neither.
You just write the sequence is arithmetic or no?
You could put no. Yes, you could. All right, but this is not arithmetic because, guys, stop. Because the next term is not found through addition or subtraction. It's dividing, not adding or subtracting. Arithmetic means it adds or subtracts.
Well, how do you know? How do you know the first one and the second one are divided?
Because 16 to.
Well, it's dividing by 8 each time.
Yeah.
1024 divided by 8 is 128. 128 divided by 8 is 16. 16 divided by 8 is 2. This is geometric, and we'll talk about geometric sequences when we talk about exponentials in next unit. That's the next
So
unit.
you literally just have to guess what number it is?
It's not really guessing. You can figure it out, and we'll show you guys how to do that when it gets to that point.
Okay.
Those words themselves are more confusing than the actual problem.
Whatever. Arithmetic. Brian, is the next one arithmetic? Why not?
Because you're adding different numbers.
Yeah, it's 4, 4, and then 6, right? So it's not arithmetic because you're not adding the same number each time. Okay, we have one more slide, and then we are done.
Wait, I have another question about
Yeah.
number 6. So even if it's like constantly dividing, it's still not arithmetic.
No, it has to be addition or subtraction.
Okay.
No, that's a good question. Okay, write the next 3 terms of the sequence and then determine the common difference. Then we're going to graph it. So we need the next 3 terms and the common difference. So common difference you can write as the letter D. So if you're getting sick of writing common difference, D is what represents common difference there. So what is the common difference here? Mike, do you have a question, or are you going to tell me? What's the common difference? It's not just 1/4, it's negative 1/4. So each time you are going down by negative 1/4. So what is the next number here? So what would the next number be, Miguel, if we're going down by 1/4 each time? Huh? Is your name Miguel? Guys, come on. Okay, after that would be what, Miguel? 2 3/4. Good. And then Blaine, what would the next one be? So it would be 2 2/4, right? But 2 2/4 is the same thing as 2 and 1/2. Okay, so remember, these are your outputs. These are your outputs. Remember, each one represents an n value. So the first one is 1, 2, 3, 4, 5, 6, and 7. So it's giving you the outputs, and you need to realize that that's when n is 1, when n is 2, when n is 3, when n is 4, and when n is 5. You should be writing all that down. Everything that I have on there, you should write down. So we are going to graph this on the graph. We start at 1, 2, 3, 4, 5, 6, and 7. And we need to get through 4 on there. So if I count by halves, does that, or by fourths, does that work? 4th, half, 4th, 1. 4th, half, 4th, 2. 4th, half, 4th, 3. So that doesn't work. So we're going to have to count by halves. If it is arithmetic, do you connect the points?
No.
No, this is a pattern. We are not connecting the points. So at 1, we are at 4. At 2, we are at 3 3/4. At 3, we're at 3 1/2. At 4, we're at 3 1/4. At 5, we are at 2. Or at 3, I'm sorry. At 6, we're at 2 3/4. And then we're at 2 1/2. So, again, you're not going to connect your points. This is arithmetic. So you'll notice, and you'll see this on the homework assignment, that the axes are drawn in for you because of this. So this is just the first quadrant, and this one is just the fourth quadrant, that lower right-hand quadrant, because of how this is working out. Okay, what are my next 3 points, Justin Crater, in this one? And number 9, what are my next 3 points? So, Cassie, what is my common difference? So remember, these are all outputs. And then that means that this is 1, 2, 3, 4, 5, 6, and 7. So again, it gave you only the last quadrant based on the fact that these are all negative, right? Make sure you realize that this is the 0, 0 point. So this is 1, 2, 3, 4, 5, 6, and 7. If you're starting at 0 and you're going down, it's going to become negative. So we are going to just count by ones here. 14 will be right off the graph, so it's not that bad.
2.6 eating.
Why are you writing... What?
I don't know.
Really don't need a calculator for this, so I don't know how you got there. Okay, so then we plot our points. At 1, we're at -2. At 2, we're at -4. At 3, we're at -6. At 4, we're at -8. 5, -10. 6, -12. And then 7, -14. All right, so what questions do you guys have for me?